The metal tube felt impossibly light in Hauptmann Friedrich Weber's hands. He turned it over slowly in the dim winter light filtering through the frosted windows of the Kummersdorf Proving Grounds, 25 kilometers south of Berlin. It was the morning of January 7th, 1944, and the object before him, captured 3 weeks earlier from American forces in Italy, seemed almost laughable in its simplicity. "This is what they're using," Weber muttered to his colleague, Oberleutnant Klaus Hartmann, who stood nearby examining the weapon's optical sight. "It looks like something a machinist apprentice would build in his first week." The weapon was crude by German engineering standards. A simple steel tube, roughly 1.5 meters long, with a rudimentary shoulder stock welded to one end and a basic wire mesh blast shield near the front grip. The Americans called it a bazooka, apparently named after some comedian's musical instrument. Weber had seen the intelligence reports. He knew that thousands of these devices were now in the hands of ordinary American infantrymen across every theater of the war. And that knowledge troubled him far more than he wanted to admit. The tube itself was smooth bore, requiring none of the precision rifling that German anti-tank weapons demanded. The rocket projectile, designated M6A3 by American nomenclature, sat in a wooden crate nearby, looking equally unsophisticated. A simple fin-stabilized rocket with a shaped charge warhead, powered by what appeared to be commercial-grade solid propellant. No complex fusing mechanism. No carefully machined components. Just stamped metal, welded seams, and mass production efficiency. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber had spent the last 6 years of his career in the Wehrmacht's Ordnance Testing Division, evaluating everything from the Panzerfaust 39 anti-tank rifle to the formidable 88mm flak gun repurposed for anti-armor work. He understood weapons. He understood the precision engineering that went into creating effective anti-tank capabilities. And everything about this American device violated those principles. Yet the reports from the front couldn't be ignored. Since the Allied landings at Salerno in September of 1943, German after-action reports had been filling with disturbing accounts. Panzer Mark III. Tanks, previously considered adequately armored for infantry support roles, were being knocked out by lone American soldiers hiding in rubble. Panzer Mark IV crews reported catastrophic penetrations from weapons that left no traceable firing position, no heavy recoil signature, no substantial muzzle flash, nothing that indicated the presence of traditional anti-tank guns. The first captured example had arrived at Kummersdorf in mid-December, shipped from Italy along with, say, a hastily written field report from a Panzer battalion commander. The report's tone had been almost apologetic, as if the officer himself couldn't quite believe what he was describing. The Americans appear to have equipped their infantry sections with man-portable anti-tank rockets of surprising effectiveness. Penetration capability exceeds that of our Panzerfaust 39. Range appears to be approximately 150 meters, possibly more. Recommend immediate technical evaluation. Now, standing in the cold testing facility with the weapon in his hands, Weber was beginning to understand why that battalion commander had sounded so uncertain. This device shouldn't work. It violated too many principles of proper weapons design. German anti-tank weapon development had always followed a clear philosophy: precision, power, and technical sophistication. The Panzerfaust 39 anti-tank rifle, introduced in 1940, featured a precision-rifled barrel, carefully designed ammunition, and required extensive training to use effectively. When that proved inadequate against heavier Soviet armor, German engineers had responded with the Panzerfaust, a brilliant if complex-shaped charge weapon that demanded careful handling and offered only a single shot before requiring complete replacement. The Panzerfaust itself represented the cutting edge of German infantry anti-tank capability. Introduced in 1943, it used a sophisticated shaped charge warhead capable of penetrating 140 millimeters of armor at 60 meters. But each Panzerfaust was essentially a disposable launcher and projectile combined into one unit, complex to manufacture, expensive in terms of materials and machining time, issued sparingly to specially trained personnel. And here was this American tube, reusable, simple, apparently issued to ordinary riflemen like candy. Weber set the launcher carefully on the workbench and picked up the rocket projectile. The M6A3 round weighed just under 1.5 kilograms. Its shaped charge warhead measured 59 millimeters in diameter, smaller than German-shaped charges, which should have limited its penetration capability. The rocket motor left a visible smoke trail, making the shooter's position obvious. The wire-guided tail fins looked like they'd been stamped out in a factory producing kitchen utensils. "Have we tested it yet?" Hartmann asked, still examining the optical sight with evident disdain. The sight itself was another piece of apparent simplicity, just a basic peep sight calibrated for range estimation. No complex optics. No precision adjustments. "Tomorrow morning," Weber replied. "We've prepared 3 captured Panzer Mark III hulls as targets at various ranges. One at 50 meters, one at 100, one at 150. We'll test penetration capability against 40 millimeter frontal armor, 30 millimeter side armor, and 20 millimeter rear armor." The numbers, the TAE, were routine, standard testing protocol, but Weber felt an unfamiliar tension as he reviewed them. The Mark III, once the backbone of German panzer divisions, had been gradually phased out of frontline service as Soviet armor improved. Its armor protection, 50 millimeters maximum on later models, often less, had been adequate in 1940 and 41. But by 1944, with heavier Soviet tanks dominating the Eastern Front, the Mark III survived mainly in secondary theaters and training units. 50 millimeters. The number hung in Weber's mind as he looked at the crude American rocket. Intelligence estimates suggested the shaped charge warhead could penetrate somewhere between 70 and 90 millimeters of armor plate. If true, that meant every Mark III and early Mark IV in the Wehrmacht inventory was vulnerable to a weapon that could be carried by a single infantryman and fired from behind cover. But surely those estimates were wrong. Shaped charge technology was sophisticated. The Germans had pioneered it. The precision required to create the correct standoff distance, the exact cone angle, the proper detonation sequence. These weren't things that could be achieved with stamped metal and welded seams. "The Americans don't understand engineering," Hartmann said, echoing Weber's thoughts as he set down the optical sight. "Look at this. Everything about it is crude. They've simply tried to achieve through quantity what we accomplished through quality." It was a common refrain in Wehrmacht technical circles. American industry produced vast quantities of adequate equipment. German industry produced smaller numbers of superior equipment. The Tiger tank, the Panther, the revolutionary STG-44 assault rifle. These were weapons built to exacting standards, incorporating advanced metallurgy and sophisticated design principles. American Shermans, by contrast, were welded boxes powered by commercial truck engines. Reliable, yes. Easy to produce in enormous numbers, yes. But inferior to German armor in almost every technical specification. This bazooka fit that pattern perfectly. A crude device, mass-produced, probably issued in quantities that German logistics couldn't hope to match. But crude meant ineffective. It had to. Weber had built his career on that assumption. He'd joined the Wehrmacht in 1935, part of the massive expansion following the reintroduction of conscription. His background in mechanical engineering, he'd studied at the Technical University of Berlin before the Depression curtailed his academic career, had marked him for ordnance work rather than frontline service. By 1939, he was evaluating weapons at Kummersdorf, the massive proving ground that had tested everything from the 88mm gun to experimental rocket artillery. The work had given him a front-row seat to German technical superiority. He'd watched the evolution of anti-tank weapons from the early 37mm Pak guns through to the devastating 88. He'd seen German-shaped charge development produce the Panzerfaust and the Panzerschreck. He understood the physics, the metallurgy, the precision machining required to create effective armor penetration. And he'd watched German weapons consistently outperform captured Allied equipment. The Soviet anti-tank rifles that fell into German hands in 1941 had been heavy, cumbersome, and marginally effective. British anti-tank guns captured in France showed adequate engineering but lacked the sophisticated fire control systems German gunners enjoyed. American equipment captured in North Africa revealed the same pattern: adequate, numerous, but technically unremarkable. Now, in January of 1944, the war had changed considerably from those early victories. The Eastern Front had become a grinding, attritional nightmare. The Italian campaign had bogged down into mountain warfare that negated German armor advantages, and the anticipated Allied invasion of France loomed somewhere in the coming months, promising to open yet another front that would strain German resources past breaking point. But German technical superiority remained an article of faith. It had to, because it was one of the few advantages the Wehrmacht still possessed. Soviet industry had proven capable of producing tanks in quantities that German factories couldn't match. But German tanks were better, more heavily armored, more powerfully gunned, more sophisticated in their engineering. American industry dwarfed German production capacity, but American equipment was crude, simple, built for quantity rather than quality. The bazooka embodied that crudeness. Weber could see it in every aspect of the weapon's construction. The tube showed visible welding seams. The electrical firing system, triggered by a simple battery connected to an igniter in the rocket motor, was basic enough for a radio technician to understand in minutes. The sight required no special tools to adjust. The rocket projectile could be loaded by someone with minimal training. It was the opposite of sophisticated German engineering, which meant it should be the opposite of effective. The testing schedule called for live fire trials to begin at 0800 hours the following morning. Weber had arranged for a full documentation team, engineers to measure penetration depth and cavity diameter, photographers to record the results, ballistic specialists to analyze the rocket's flight characteristics. Standard protocol for captured weapons evaluation. He expected the results to confirm what the weapon's appearance suggested: adequate penetration against light armor at close range, declining effectiveness at distance, inconsistent accuracy due to the crude stabilization system. Dangerous in the right circumstances, certainly, but not fundamentally threatening to German armored doctrine. The alternative, that this simple tube could genuinely threaten German armor at the ranges and effectiveness levels the field report suggested, was too disturbing to seriously consider. Because if the Americans had truly created an effective anti-tank weapon, this simple, this cheap, this easy to produce in quantity, then they could equip every infantry squad in their army with organic anti-armor capability. No need for specialized anti-tank gun crews, no need for careful positioning of heavy-towed weapons, just ordinary riflemen, hiding in buildings or tree lines, capable of destroying tanks worth hundreds of thousands of Reichsmarks with a device that probably cost less than a decent rifle to manufacture. The implications extended beyond mere tactical concerns. German strategy in the coming year depended heavily on armored reserves, concentrated panzer divisions held back from the coast, ready to counterattack any Allied landing and drive it back into the sea before the invasion could establish a secure lodgment. Those panzer divisions represented Germany's best hope of defeating the inevitable Allied assault on France. But if American infantry could kill German tanks as easily as the field reports suggested, then those armored reserves would bleed away their strength fighting through infantry that should have been helpless against armor. Every Panzer Mark IV, knocked out by a rifleman with a bazooka, was one less tank available for the crucial counterattack. Every tank commander forced to button up his hatches and reduce his situational awareness because of the threat of infantry. Anti-tank weapons was a commander who couldn't lead effectively. Weber pushed the thoughts aside. He was allowing field reports and speculation to override his engineering judgment. Tomorrow's testing would provide concrete data. Until then, worrying about strategic implications was premature. He picked up the technical documentation that had accompanied the captured weapon, a mixture of hastily translated American training manuals and intelligence summaries compiled from prisoner interrogations. The manual was remarkably straightforward. The 236-inch rocket launcher M9 is a smoothbore, muzzle-loaded weapon designed to launch fin-stabilized rockets against armored vehicles and fortified positions. Effective range, 120 yards against stationary targets, 80 yards against moving targets. Penetration, 4 inches of armor plate at all ranges within the weapon's effective envelope. 4 inches. Weber did the mental conversion, roughly 100 millimeters. If true, that meant the bazooka could penetrate the frontal armor of every German tank except the Tiger and Panther. The Panzer Mark IV, with 80 millimeters of frontal armor on its latest models, would be vulnerable. The Panzer Mark III was practically defenseless. But the manual was American propaganda, designed to boost the confidence of soldiers using the weapon. Real-world penetration was always less than manufacturer claims. The testing would reveal the truth. Hartmann had moved to the window, staring out at the snow-covered testing ranges visible in the distance. "The Panzerschreck program is moving forward," he said quietly. "Have you seen the prototypes?" Weber nodded. The Panzerschreck, officially designated Raketenpanzer Büchse 54, was Germany's response to the bazooka threat, essentially a scaled-up copy of the American weapon, modified to fire a larger 88-millimeter rocket with greater penetration capability. The first prototypes had arrived at Kummersdorf in late November, and production was scheduled to begin in the coming months. It was an admission, though no one stated it explicitly. If Germany was copying the American design, that meant German engineers had concluded the basic concept was sound. But the Panzerschreck retained German engineering philosophy, heavier, more powerful, more sophisticated than its American counterpart, an improved version of the crude American original. Penetration estimates are around 160 millimeters, Hartmann continued, enough to threaten even the Sherman from the front at close range. And it maintains the reloadability of the American design. One launcher, multiple rockets. "Production numbers?" Weber asked, though he already knew the answer would be discouraging. "Initial allocation is 40,000 launchers for 1944, with 200,000 rockets. Conditional on materials availability." Weber did the arithmetic silently. 40,000 launchers for the entire Wehrmacht, spread across every front, assuming production goals were met and raw materials remained available. Meanwhile, intelligence estimates suggested the Americans had already fielded over 100,000 bazookas, with production continuing at a rate Germany couldn't hope to match. The numbers told a story that Weber's engineering training made impossible to ignore. Even if German weapons were technically superior, more powerful, more sophisticated, better engineered, sheer quantity possessed a quality all its own. An American infantryman with a crude but functional bazooka was infinitely more dangerous than a German infantryman with no anti-tank capability at all. And America could apparently equip every squad with bazookas, while Germany struggled to produce enough Panzerschrecks for specialized units. It was the same pattern visible across every aspect of the war economy. German factories produced superb equipment in limited quantities. American factories produced adequate equipment in overwhelming quantities. The Tiger tank was a masterpiece of engineering, mounting an 88-millimeter gun that could destroy any Allied tank at ranges exceeding 2 kilometers. But Germany would produce fewer than 1,500 Tigers during the entire war. America would produce over 40,000 Sherman tanks, individually inferior, collectively overwhelming. The bazooka fit perfectly into that industrial philosophy. Simple enough to manufacture in massive quantities, reliable enough to function in field conditions, effective enough to achieve the tactical goal of killing tanks. Not elegant, not sophisticated, just functional. And perhaps, Weber was beginning to suspect, that was a different kind of genius than the one German engineering culture celebrated. He looked again at the crude tube resting on the workbench. Tomorrow's testing would provide answers. Until then, he could only wait and wonder whether the Wehrmacht's faith in technical superiority was about to collide with an uncomfortable truth about modern warfare. The sun was setting over Kummersdorf, casting long shadows across the proving ground. Weber carefully packed the bazooka and its rockets into their storage crate, noting with professional precision how the Americans had designed even the packaging for simplicity and speed. The rockets nested in foam cushions that could be pulled out quickly. The launcher itself broke down into 2 pieces for transport, secured with simple pins rather than complex fittings. Everything about the weapon spoke of mass production and field utility. Nothing about it spoke of the precision engineering that German military culture valued, and yet soldiers were dying to it on multiple fronts. That fact, more than any technical specification, demanded explanation. Hartmann left first, heading back to his office to prepare the next day's documentation requirements. Weber remained in the testing facility for another hour, examining the weapon from every angle, trying to understand what the field reports were telling him. The shaped charge warhead showed competent but not exceptional design. The rocket motor burned dirty, leaving residue that would make the launcher's position obvious. The electrical firing system was vulnerable to moisture and rough handling. It was a weapon full of compromises and limitations, but it was also a weapon that existed in quantities German logistics couldn't match, in the hands of soldiers who required minimal training to use it effectively. And sometimes, Weber was beginning to realize, that might matter more than engineering excellence. He locked the testing facility and walked through the January darkness toward his quarters, his breath forming clouds in the frozen air. Tomorrow would bring data, numbers, objective measurements of penetration depth and accuracy at range. The kind of concrete information that engineering decisions should be based on. But as he walked, Weber couldn't shake the feeling that tomorrow's tests were going to challenge assumptions he'd held for his entire career. The Americans had done something the Wehrmacht hadn't. They'd made anti-tank capability democratic, spreading it across their entire infantry force instead of concentrating it in specialized units. Whether that represented engineering weakness or strategic insight remained to be seen. The proving ground was quiet. The testing, ranges empty and snow-covered. In 8 hours, those ranges would echo with the sound of American rockets striking German armor. And Weber would finally have the data to answer the question that had been troubling him since the first field reports arrived. Was the bazooka's crudeness a weakness to be exploited, or a strength that the Wehrmacht had failed to recognize. The morning of January 8th arrived with the gray, colorless light characteristic of German winters. Weber reached the testing facility at 0730, finding the documentation team already preparing their equipment. The 3 Panzer Mark III holes sat at their designated distances, 50, 100, and 150 meters, their armor plates marked with white chalk squares to indicate aim points. The tanks themselves were veterans of the Eastern Front, withdrawn from service after mechanical failures or battle damage. The nearest hull showed extensive scarring on its frontal armor from Soviet anti-tank rounds that had failed to penetrate. The turret was missing, removed for another testing program. What remained was the basic hull, 30 millimeters of armor on the sides and rear, 50 millimeters on the front, angled at 9 degrees from vertical. Adequate protection against rifle-caliber weapons and shell fragments. Marginal protection against dedicated anti-tank guns. Unknown protection against this crude American rocket. Weber supervised the setup of the Bazooka firing position, a simple earthwork revetment constructed the previous day to protect the testing crew from backblast. The weapon itself lay on a wooden rest, pointed downrange toward the first target. 6 M6A3 rockets waited in their shipping container, their fins folded for storage. "Ready when you are, Herr Hauptmann," the senior ballistics technician reported. His crew had positioned high-speed cameras at angles to capture the rocket's flight path and impact. Measurement equipment stood ready to document penetration depth and cavity formation. Weber picked up the bazooka, feeling again that unsettling lightness. The weapon weighed just under 6 kilograms when loaded, less than the Panzer 39 anti-tank rifle, far less than any towed anti-tank gun. A single soldier could carry it all day without significant fatigue, plus several rockets in a backpack. Loading the rocket proved as simple as the training manual suggested. The projectile slid smoothly into the rear of the tube until its fins locked into place against a simple catch mechanism. Weber connected the electrical firing wire to the battery pack worn on a belt. Again, simple commercial components rather than specialized military hardware. The whole loading process took perhaps 15 seconds. He settled the launcher onto his shoulder, peering through the basic optical sight. The target was clearly visible at 50 meters, the chalk aiming square, stark white against the dark gray armor plate. Weber adjusted his position, slightly, feeling the weapon's balance. The center of gravity was good, naturally pointing toward the target without requiring significant muscle tension to hold steady. "Firing!" he called and squeezed the trigger. The electrical contact sparked the rocket motor igniter. For a fraction of a second, nothing seemed to happen. Then the rocket motor ignited with a whoosh of flame and smoke that erupted from both ends of the tube. Weber felt modest recoil, far less than a rifle, as the rocket accelerated down the tube and into free flight. The flight time at 50 meters was barely perceptible. The rocket crossed the distance in a nearly flat trajectory, its tail fins stabilizing the flight path, and struck the Panzer Mark III's frontal armor with a sharp crack that echoed across the proving ground. Even from 50 meters away, the results were visible. The shaped charge warhead had detonated on contact, its copper jet cutting through the armor plate like a torch through paper. A neat circular hole, perhaps 7 centimeters in diameter, marked the entry point. Smoke rose from the penetration. Weber set down the launcher carefully and walked toward the target, aware that the documentation team was following with their measurement equipment. The walk felt longer than 50 meters. Each step brought him closer to data that would either confirm his assumptions or challenge them fundamentally. The frontal armor plate showed catastrophic penetration. The shaped charge jet had burned completely through the 50-millimeter armor, creating an entry hole surrounded by melted metal. Weber crouched beside the hull and peered through the penetration. Morning light shone through from the other side. The jet had continued through the crew compartment and struck the rear armor, leaving a spall pattern on the interior surface. The ballistics technician arrived with his measuring equipment. Entry diameter, 71 millimeters. Clean penetration through 50 millimeters of armor plate. Interior cavity shows typical shaped charge characteristics: metal splash, thermal effects, complete perforation. Weber straightened, processing the information. 50 millimeters of armor. The bazooka had punched through it as effectively as any anti-tank gun, at 50 meters range, fired by a weapon that weighed 6 kilograms and could be operated by a single soldier with minimal training. "Continue testing," he ordered, his voice professionally neutral. 100-meter target, side armor. The second shot followed the same procedure: loading, aiming, firing. The rocket flew true, striking the side armor 30 meters at the 100-meter distance. The thinner 30-millimeter armor offered even less resistance. The penetration was clean and catastrophic. The third shot, at 150 meters against rear armor, produced similar results. 20 millimeters of armor plate meant almost nothing to the shaped charge warhead. The rocket's flight path showed some dispersion at the longer range. The crude fin stabilization wasn't as accurate as a rifled projectile, but combat accuracy at 150 meters was clearly achievable. By 0900 hours, the testing was complete. 6 rockets fired, 6 penetrations achieved. The bazooka had performed exactly as the American training manual claimed: 4 inches of armor penetration, effective range out to 150 meters or more, reliable ignition and flight characteristics. Weber stood beside the 100-meter target, staring at the neat hole burned through the side armor. The documentation team was photographing the penetrations from multiple angles, measuring cavity dimensions, collecting data that would be compiled into a formal report for Wehrmacht Ordnance Headquarters. But the numbers, Weber knew, would only confirm what was already obvious. The Americans hadn't created a crude anti-tank weapon that happened to work despite its simplicity. They'd created an effective anti-tank weapon that worked because of its simplicity. Every aspect of the design, the smoothbore tube, the fin-stabilized rocket, the simple-shaped charge warhead, the electrical firing system, represented a conscious choice to prioritize functionality, manufacturability, and ease of use over technical sophistication. And it worked. At ranges where German tank crews expected to be safe from infantry anti-tank weapons, the bazooka could kill. Against armor protection that should have been adequate, the bazooka could penetrate. In the hands of soldiers who weren't specialists, who hadn't spent months training on complex equipment, the bazooka could be employed effectively. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Hartmann approached from the firing position, carrying the now empty launcher. "Impressive results," he said quietly. "The penetration characteristics exceed our initial estimates." Weber nodded slowly. "Every Panzer Mark III in the Wehrmacht inventory is vulnerable. The Mark IV's side and rear armor as well. Even the frontal armor on early Mark IV models. The Americans have equipped their infantry squads with these," Hartmann continued. "Intelligence estimates suggest 2 per rifle platoon, possibly more in certain specialized units. That's, potentially thousands of these weapons in Italy alone?" The implications hung unspoken between them. Thousands of American infantry soldiers, each capable of destroying German tanks that represented months of factory production time, years of crew training, strategic resources that Germany could no longer easily replace. And this was just Italy. When the invasion of France came, and everyone knew it was coming, those thousands would become tens of thousands. Weber turned away from the penetrated armor, looking back across the proving ground toward the testing facility. The Panzer Schreck prototypes waited there, representing Germany's attempt to match and exceed the American weapon. Larger rockets, greater penetration, sophisticated improvements on the basic design. But the improvements came at a cost. The Panzer Schreck was heavier, more complex, more demanding of materials and manufacturing capacity that Germany no longer possessed in abundance. It would be issued sparingly to specialized units, in quantities that would never match American bazooka production. Germany was responding to American quantity with German quality. But what if quantity was itself a form of quality? What if the ability to put an anti-tank weapon in the hands of every infantry squad mattered more than having the most sophisticated anti-tank weapon in the hands of specialized troops? The formal testing report took 3 days to compile. Weber spent those days reviewing the data, examining the photographs, and correlating the Kummersdorf results with field reports that continued to arrive from Italy and the Eastern Front. Each report added another piece to a picture that was becoming increasingly difficult to ignore. A Panzer Mark IV company operating near Cassino reported losing 2 tanks in a single day to what crews described as infantry rocket weapons fired from building windows. The after-action report noted that the weapons left minimal visual signature, just a puff of smoke and a brief rocket trail, making counter-battery fire nearly impossible. Traditional anti-tank guns revealed their positions through muzzle flash and recoil. The bazooka shooter could fire and immediately displace to a new position. From the Eastern Front came accounts of American-supplied bazookas in Soviet hands. A Panzer regiment near Vitebsk reported encountering Soviet infantry equipped with American tube weapons during a failed counterattack in late December. 3 Panzer Mark IVs destroyed, 2 more damaged, all from ranges under 150 meters in terrain that should have favored German armor. The Soviets, it appeared, had received substantial Lend-Lease shipments of bazookas and were employing them with their characteristic tactical directness. Soviet infantry doctrine had always emphasized close assault against armor. Now they possessed a tool that made such assaults devastatingly effective. Weber compiled the field reports alongside the Kummersdorf testing data, creating a comprehensive analysis that went beyond simple ballistics measurements. The picture that emerged was sobering. The bazooka represented a fundamental shift in infantry armor dynamics, one that German doctrine hadn't adequately prepared for. Traditional anti-tank defense relied on specialized weapons, towed guns, tank destroyers, heavy anti-tank rifles, concentrated in dedicated units. Infantry formations expected to defend against armor would position these specialized weapons at likely approach routes, creating kill zones that attacking tanks had to either avoid or suppress. The system worked because anti-tank weapons were relatively scarce, expensive, and required specialized training to operate effectively. The bazooka shattered that model. When every American infantry squad potentially possessed organic anti-tank capability, German armor could no longer assume that avoiding known anti-tank gun positions meant safety. Every building, every tree line, every depression in the ground could conceal an infantry soldier with a bazooka. The weapon's portability and ease of use meant that American commanders could distribute anti-tank capability across their entire defensive front, rather than concentrating it at predicted approach routes. For German panzer tactics, the implications were profound. The doctrine of rapid breakthrough, concentrating armor at weak points to rupture enemy lines, depended on the ability to identify and avoid or suppress enemy anti-tank concentrations. But if anti-tank capability was dispersed throughout the American defensive system, then every meter of advance became potentially lethal. Panzer crews would have to button up their hatches, reducing visibility and situational awareness. Infantry support would become mandatory even in situations where armor should have been able to operate independently. The psychological impact was perhaps worse than the tactical problems. German panzer crews had been trained to respect enemy anti-tank guns while remaining confident in their armor protection against ordinary infantry. The bazooka destroyed that psychological comfort. Any American soldier might be carrying a weapon capable of killing a tank. The rifleman crouching in a foxhole wasn't just a target for the tank's machine guns. He was a potential threat to the tank itself. Weber's report documented all of this with Germanic thoroughness, penetration data, range estimates, accuracy calculations, but also tactical analysis, doctrinal implications, and strategic concerns about American production capacity versus German ability to field countermeasures. The report concluded with a section that Weber had revised multiple times, trying to find language that conveyed the severity of the situation without appearing defeatist. The M9 bazooka represents a significant advancement in infantry anti-tank capability. Its effectiveness is derived not from technical sophistication, but from tactical accessibility. The weapon's simplicity enables mass production and widespread distribution to ordinary infantry. This distribution fundamentally alters the infantry armor engagement dynamic in ways that favor defensive operations and attritional warfare over mobile breakthrough tactics. He didn't write what he was really thinking, that the Americans had stumbled onto or deliberately created a weapon system that perfectly countered German tactical doctrine, that this crude tube represented a more sophisticated understanding of modern warfare than all of Germany's precision-engineered technical marvels, that sometimes the best solution wasn't the most elegant one, but the one that could be fielded in overwhelming numbers. The report went up through channels in mid-January. Weber received acknowledgement of its receipt, but no immediate response. Kummersdorf was one testing facility among many, and the Wehrmacht's senior leadership had more immediate concerns than the technical characteristics of captured American equipment. But the field reports kept coming. By February of 1944, the pattern was undeniable. American infantry in Italy were employing bazookas aggressively and effectively. German tank losses to infantry anti-tank weapons were climbing month over month, and the Americans, according to intelligence estimates, were still ramping up bazooka production to supply the anticipated invasion of France. Weber began receiving requests for additional analysis. How effective was the bazooka in urban terrain? What countermeasures could reduce its effectiveness? Could additional armor be added to vulnerable German tanks without compromising mobility? Each question revealed growing concern at higher command levels about a weapon that had initially been dismissed as crude American improvisation. The urban terrain question was particularly troubling. The bazooka's short range, 100 to 150 meters, was less of a limitation in cities, where sight lines were naturally restricted and buildings provided abundant firing positions. An American soldier in a second-story window could engage German armor from above, where even the thickest frontal armor gave way to thinner deck plates. The bazooka shooter could fire, withdraw deeper into the building, and relocate before German infantry could respond. Italy's towns and villages were becoming graveyards for German armor. Monte Cassino, Anzio, the approaches to Rome, everywhere German panzers operated in built-up areas, bazookas took their toll. The weapons weren't destroying entire tank formations, but they were inflicting steady, grinding losses that Germany couldn't afford. Each destroyed Panzer Mark IV represented production capacity that would have been better used building Panthers or Tigers. Each killed crew took months of training time that Germany no longer had in surplus. And this was before the main event, The invasion of France, when it came, would bring the full weight of American industrial production crashing against German defenses. If the Americans were fielding bazookas by the thousands in Italy, how many tens of thousands would they bring to France? The Panzerschreck program accelerated in response to the growing threat. By March of 1944, production had begun in earnest at several facilities across Germany. The weapon was larger than the American bazooka. The 88mm rocket provided substantially greater penetration capability, but it retained the fundamental concept: a simple tube, a shaped charge rocket, reloadability, and ease of use. Weber tested the early production models in late March. The Panzerschreck was heavier than the bazooka, 11 kilograms versus 6, and the larger rockets were correspondingly more cumbersome. But the penetration results were impressive. Against a captured Soviet T-34 tank hull, the Panzerschreck's rocket punched cleanly through 100 millimeters of armor at 100 meters. Even the Sherman's frontal armor, 76 millimeters on later models, would be vulnerable. It was a German engineering response to an American innovation. Take the basic concept and make it bigger, heavier, more powerful. The Panzerschreck could do everything the bazooka could do, only more so. In technical terms, it was superior. But technical superiority didn't address the fundamental problem. Germany would produce perhaps 150,000 Panzerschrecks during 1944 and 45, a substantial number, but still only a fraction of total Wehrmacht infantry strength. The weapons would be issued to designated anti-tank troops, specialist units, and selected infantry formations. Most German infantry squads would never see a Panzerschreck. Meanwhile, American production estimates suggested they would field over 400,000 bazookas by the end of 1944, enough to equip every rifle company in the U.S. Army multiple times over. The disparity in numbers was almost comical, except that it represented a strategic reality that Germany couldn't overcome through superior engineering alone. Weber understood this with the clarity that comes from working with concrete data rather than hopeful assumptions. He'd spent months examining captured American equipment, not just the bazooka, but also trucks, radios, field rations, ammunition crates, all the mundane logistics of industrial warfare. And a pattern had emerged. American equipment was rarely the best in its category from a pure engineering standpoint. German trucks had better cross-country performance. German radios had greater range and clarity. German field rations, when available, were more nutritionally complete. But American equipment had one overwhelming advantage. It existed in quantities that German logistics could only dream about. The bazooka embodied that advantage. It wasn't the most powerful infantry anti-tank weapon. The German Panzerfaust, in its later variants, actually had superior penetration. It wasn't the longest-ranged, dedicated anti-tank guns could engage at distances the bazooka couldn't hope to match. It wasn't even particularly sophisticated. German shaped charge research was ahead of American developments in several key areas. But the bazooka could be manufactured in vast quantities using industrial processes that didn't require precision machining. It could be issued to ordinary soldiers without extensive training. It could be carried alongside standard infantry equipment without significantly burdening the soldier. And it worked. Reliably in field conditions that would have disabled more sophisticated weapons. That combination, adequate performance, mass producibility, ease of use, represented a design philosophy fundamentally different from German engineering culture. German weapons design prioritized technical excellence, often at the cost of production complexity and manufacturing time. The Tiger tank was a masterpiece, but it required thousands of man-hours to build and constant maintenance to keep operational. The Panther was arguably the best medium tank of the war, but its sophisticated transmission and final drive units were prone to failure and difficult to replace in field conditions. The Bazooka represented the opposite approach, designed for the lowest common denominator, accept technical compromises in favor of manufacturability, prioritize quantity over individual unit capability. It was engineering as industrial strategy rather than technical achievement. And it was working. By April of 1944, Weber had been reassigned from pure testing work to helping develop tactical countermeasures against the bazooka threat. The work was frustrating because the countermeasures were all partial solutions to a systemic problem. Additional armor could be added to tanks, but weight penalties reduced mobility and increased mechanical strain. Scherzen, thin armor skirts mounted around turrets and hulls, could detonate shaped charges prematurely, but they were vulnerable to damage and added weight. Infantry screens could protect advancing tanks, but close infantry armor cooperation required training and coordination that many Wehrmacht units no longer possessed after years of attritional losses on the Eastern Front. The fundamental problem remained. The Americans had democratized anti-tank warfare. They'd taken a capability that had previously required specialized units and expensive equipment and made it available to every infantry soldier. German tactical doctrine had no answer to that, except to accept higher casualties and adapt operational planning to account for ubiquitous infantry anti-tank capability. The invasion of France, when it finally came on June 6, 1944, validated every concern Weber had documented in his January report. American infantry came ashore at Normandy carrying bazookas in quantities that German intelligence had underestimated even in pessimistic projections. The hedgerow country of Normandy, with its limited sight lines, abundant cover, and restricted maneuver space, proved ideal terrain for bazooka employment. German panzer divisions attempting to counterattack the beachhead found themselves engaged by American infantry at ranges where tank main guns couldn't effectively respond. Bazookas fired from hedgerows, from buildings, from hastily dug foxholes. The weapons weren't destroying entire panzer companies, but they were inflicting steady losses that accumulated into strategic significance. A Panzer marked force company that began an engagement with 14 tanks might lose 2 or 3 to bazookas during a single day of combat. Not catastrophic in tactical terms, the company remained combat effective. But those losses, multiplied across dozens of engagements, across multiple panzer divisions, over weeks and months of continuous combat, added up to an attrition rate that German industry couldn't replace. By July, field commanders were submitting urgent requests for more Panzerschrecks, more infantry anti-tank training, more tactical guidance on countering ubiquitous American anti-tank capability. The responses from Wehrmacht headquarters were professionally worded variations on "resources are limited, make do with what you have." Weber, still at Kummersdorf, but now consulting on tactical doctrine development, read these reports with a growing sense of vindication mixed with dread. He'd been right about the bazooka's significance. But being right didn't change the strategic reality. Germany was fighting an industrial war with inadequate industrial capacity, and the bazooka was just one example among many of how American production capability was overwhelming German technical sophistication. In August, he received an unusual assignment: evaluate a proposal to retrofit existing Panzer Mark IV tanks with additional armor specifically designed to counter shaped charge weapons. The proposal called for installing spaced armor plates around the hull and turret, creating an air gap that would disrupt the shaped charge jet before it reached the main armor. The engineering was sound. Testing showed that properly spaced armor reduced penetration by 30 to 40%, enough to make the Panzer Mark IV substantially more survivable against bazookas and similar weapons. But the retrofit required additional steel, specialized mounting brackets, and factory time that Germany didn't have. Each tank sent back for retrofit was a tank unavailable at the front. Each kilogram of steel used for spaced armor was steel not available for new tank production. Weber's evaluation report recommended against large-scale implementation, not because the solution didn't work, it did, but because Germany lacked the industrial capacity to implement it without further degrading already inadequate tank production. Better to accept bazooka losses than to reduce the flow of new tanks to frontline units. It was a calculus that would have been unthinkable in 1940, when German production capacity exceeded demand, and the Wehrmacht could afford to prioritize quality over quantity. By 1944, those luxuries no longer existed. Germany was fighting with what it had, and what it had was never enough. The bazooka itself underwent American improvements during 1944. The M9A1 model, introduced in mid-year, featured modifications based on combat experience, improved sights, better weatherproofing, a reinforced tube. Nothing revolutionary, just incremental. Improvements that made an already functional weapon slightly more effective. German intelligence dutifully documented these changes. Weber received samples of the improved model in September and conducted comparative testing against the original M9. The improvements were marginal from a pure performance standpoint. Penetration characteristics remained essentially unchanged, but they reflected American responsiveness to field feedback and their ability to rapidly implement manufacturing changes. It was another small example of how American industrial flexibility complemented their quantity advantage. German weapons development was thorough and sophisticated, but it was also slow. The time from concept to field deployment for new German weapon systems often measured in years. American development cycles were faster, more iterative, more willing to field good enough solutions and improve them based on combat experience. The bazooka had entered service in 1942 as a functional but imperfect weapon. By 1944, it had been refined through multiple iterations into a mature system that balanced effectiveness, manufacturability, and ease of use. The development process hadn't aimed for technical perfection. It had aimed for continuous, incremental improvement of an adequate baseline design. Germany's Panzer development followed a different path. The early models, rushed into production in response to the bazooka threat, had serious problems. The backblast was dangerous to the operator. The sight system was inadequate. The rockets were prone to moisture damage. German engineers addressed these issues methodically, producing improved variants that fixed the problems. But each improvement added complexity and manufacturing time. The RPZ-B 54-1 model, introduced in late 1944, was a far better weapon than the original RPZ-B 54. It was also more expensive to produce and took longer to manufacture. German engineering culture demanded solutions to identified problems, even when those solutions increased production costs. By the winter of 1944 to 45, the strategic situation had deteriorated past the point where weapons technology could make a meaningful difference. The Soviets were pushing into Poland and Hungary. The Americans and British were advancing toward the Rhine. Germany's industrial capacity was being systematically destroyed by strategic bombing. The question was no longer how to counter the bazooka threat. It was how to delay inevitable defeat long enough for some diplomatic miracle to save the Reich. Weber remained at Kummersdorf through the autumn, testing captured equipment and compiling reports that fewer people read and even fewer acted upon. The work had become almost archaeological, documenting the technical characteristics of Allied weapons for an audience that no longer had the resources to respond meaningfully to the information. In December, he tested a captured American M20 Super Bazooka, a 3.5-inch version, that had entered limited service late in the war. The larger rocket provided even greater penetration than the original design, enough to threaten even the Tiger's frontal armor at close range. The weapon weighed more and was less convenient to carry, but it represented another iteration of American incremental improvement. Weber's report on the M20 was perfunctory. The weapon worked as advertised. American engineers had scaled up the basic bazooka concept to provide greater anti-armor capability. Production numbers were unknown but presumably substantial. Countermeasures were the same as for the standard bazooka, with the added note that spaced armor would be less effective against the larger shaped charge warhead. The report went into files that would probably never be consulted for any operational purpose. The war was ending. Everyone knew it, even if no one said it officially. Kummersdorf itself came under threat in late January of 1945 as Soviet forces pushed toward Berlin. Weber and the remaining technical staff began preparing to evacuate or destroy sensitive materials. The captured American equipment, including the various bazooka models he'd tested over the past year, were catalogued for destruction to prevent them from falling back into Allied hands, a precaution that struck Weber as grimly ironic given how many bazookas the Americans had already. On February 3, 1945, Weber supervised the demolition of the testing facility's main laboratory. Explosive charges reduced years of accumulated research and documentation to rubble. The bazooka samples were buried under concrete and steel. Not to deny the Americans their own weapons, they had plenty, but because military regulations required the destruction of all captured enemy equipment that couldn't be evacuated. Weber spent the final weeks before the facility's complete evacuation, writing a comprehensive summary of everything he'd learned about American infantry anti-tank weapons. The document was part technical analysis, part tactical assessment, part philosophical reflection on engineering culture and industrial warfare. The conclusion he reached was one that would have seemed defeatist or even treasonous in 1941, but which by 1945 was simply obvious. Germany had lost the industrial war before the shooting even started. American production capacity, once fully mobilized, had been sufficient to overcome any German technical advantage through sheer overwhelming quantity. The bazooka was just one example among hundreds of how American industrial might had translated into battlefield superiority. But the bazooka was also something more specific. It was an example of a different approach to weapons design, one that prioritized battlefield utility over engineering elegance. The Americans hadn't tried to build the best possible infantry anti-tank weapon. They'd tried to build a good enough infantry anti-tank weapon that could be manufactured in quantities sufficient to equip their entire army. And they'd succeeded. By war's end, over 470,000 bazookas had been manufactured. German Panzerschreck production totaled approximately 290,000 units, impressive in absolute terms, inadequate relative to American numbers and Wehrmacht needs. The disparity in production illustrated a fundamental difference in strategic approach. Germany had responded to the bazooka threat by trying to build a better bazooka, the Panzerschreck, with its larger warhead and greater penetration. The Americans had responded to Germany's armored threat by building enough bazookas to ensure that German armor would face anti-tank weapons from every infantry squad on every battlefield. Quantity, in this case, had indeed become a quality all its own. Weber evacuated Kummersdorf on March 2, 1945, as Soviet artillery began ranging in on the facility. He carried with him a single briefcase of documents. His comprehensive analysis of American weapons development philosophy, some technical drawings, and his personal notes from the past 15 months of testing. The documents survived the war. Weber himself survived, surrendering to American forces in Bavaria in late April. During his interrogation by American technical intelligence officers, he discussed the bazooka testing at length, providing details on German assessments and countermeasure development. The American officers were professionally interested but not particularly surprised by Weber's conclusions. They already knew the bazooka had been effective. What interested them more was German engineering culture, and why Germany had found it so difficult to match American production efficiency. Weber tried to explain precision engineering versus mass production, technical excellence versus industrial pragmatism, the German faith in quality over quantity, the American understanding that in modern warfare, adequate equipment available in overwhelming numbers often trumped superior equipment available in limited quantities. The Americans listened politely and took notes. Then they offered Weber a position working for U.S. Army Ordnance, helping to evaluate captured German weapons technology. The irony wasn't lost on Weber. After spending years testing American equipment for Germany, he would now test German equipment for America. He accepted. The war was over. The ideology that had driven Germany to destruction was discredited, and Weber had learned enough over the past 15 months to recognize that American industrial and engineering philosophy, whatever its aesthetic shortcomings, had proven itself on battlefields across the world. The bazooka itself remained in American service for decades after the war, seeing action in Korea and Vietnam. It was eventually replaced by more sophisticated systems, but the basic concept, a simple man-portable, reloadable rocket launcher, became standard across armies worldwide. The Soviet RPG series, the Swedish Carl Gustaf, countless other systems all traced their conceptual lineage back to that crude tube Weber had first examined in January of 1944. Germany's Panzer Schreck, by contrast, disappeared with the Wehrmacht. Superior in technical terms to the bazooka, it was also more complex, more expensive, and less well-suited to mass production. After the war, when former German engineers worked on new weapon systems, they increasingly adopted American-style design philosophy: simplicity, manufacturability, and adequate performance over technical excellence. Weber himself spent the next 20 years working in the American defense industry, contributing to the development of post-war anti-tank weapons. He never forgot the morning of January 8, 1944, when he'd fired that first bazooka at Kummersdorf and watched it punch cleanly through armor that should have been adequate protection. That moment had taught him something fundamental about modern warfare, that engineering elegance mattered less than battlefield utility, that technical sophistication was meaningless if it couldn't be produced in sufficient quantities, that sometimes the crude solution, the simple solution, the good enough solution, was actually the best solution. The Americans had understood this instinctively. They'd built weapons that worked well enough, in quantities large enough, with simplicity sufficient to arm ordinary soldiers. The bazooka wasn't a triumph of precision engineering. It was a triumph of industrial democracy, the democratization of anti-tank capability, spread across an entire army through weapons simple enough for any soldier to use and cheap enough to field by the thousands. Germany had responded with technical sophistication, better rockets, more powerful warheads, improved sights and firing mechanisms, all of it superior in specifications, all of it insufficient in numbers to matter strategically. In his later years, when former colleagues asked Weber about his wartime experience, he often returned to that January morning at Kummersdorf, the shock of watching a crude American weapon perform exactly as advertised, the slow realization that German engineering culture had optimized for the wrong variables, the dawning understanding that the war had already been lost, not on any battlefield, but in the factories and industrial planning offices where America's overwhelming production capacity had been mobilized. The bazooka hadn't defeated Germany single-handedly. no one weapon system had, but it represented, in miniature, the fundamental dynamic that determined the war's outcome. American industrial might, translated into adequate equipment available in overwhelming quantities, versus German technical sophistication hampered by inadequate production capacity. Weber died in 1968, having lived long enough to see weapons technology advance far beyond the crude rockets he'd tested in 1944, guided missiles, shaped charges with sophisticated standoff mechanisms, advanced composite armor. The technology had evolved enormously, but the fundamental lesson remained valid. In modern warfare, the side that can field adequate equipment in overwhelming quantities will usually prevail over the side that fields superior equipment in limited numbers. The bazooka had proven that truth in the snows of Italy, the hedgerows of Normandy, and the forests of the Ardennes. And that truth, more than any specific technical specification, was what made Weber's testing report from January 1944 a document of lasting significance. Not because it revealed the bazooka's penetration characteristics, those were already known from American sources, but because it documented the moment when German engineering confidence collided with American industrial reality. The crude tube had been right all along, and Germany's faith in technical superiority, however well-founded in engineering terms, had been strategically irrelevant in the face of American production capacity. That was the real lesson Weber had learned at Kummersdorf. Not that German engineering was inferior, it wasn't. But that engineering excellence alone couldn't win an industrial war against an opponent who understood that sometimes good enough, repeated 500,000 times, beats perfect repeated 50,000 times. The bazooka proved it. The war proved it. And Weber, standing in that frozen testing ground in January 1944, had been among the first German officers to fully understand what it meant. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.